Hi, this is Mrs. Villette, and I'm going to show you the process for finding an inverse of a trigonometric function. So to begin with, as we do with any inverse function, is we're going to swap the x's and the y's. So we need to remember that f of x is y, so I will rewrite the same function but with the x and y swapped. So I'll say x equals the tangent of 3 times y subtract pi over 3. Because we're talking about inverse trig functions, and the original functions that we deal with are not one-to-one, we have to take an additional extra step of restricting the domain of the original function so that it's invertible. So I'm going to do that now before I do anything else. So we'll do that over here in red. We need to restrict the domain. Fortunately, we don't have to think too hard about what to restrict it to because we have some standards. The function that I'm dealing with is a tangent function. Our normal restriction that we do on a tangent function is to restrict the domain between negative pi over 2 and pi over 2, not inclusive of the endpoints. Now my particular function happens to be a tangent function with some transformations applied to it. So it has a change in the period is pi over 3, and it has a shift to the right pi over 3 units. The way I'm going to deal with those transformations is I'm just going to set this argument, whatever is inside of the function, to be restricted between that domain restriction that is already set up for me as a standard restriction. Then I just need to solve this inequality. So the easiest way to solve this inequality is to divide both sides by 3, in other words, multiply by 1/3, which gives me negative pi over 6 is less than x subtract pi over 3 is less than pi over 6. Now looking back at this, probably would have been easier just to distribute that 3 through, because now, actually, not really. I'm going to multiply both sides by, let's not multiply by 6. Let's multiply by 3. So actually it would have been easier to distribute through. The reason I'm multiplying both sides by 3 is I want to clear this denominator on the inside when I'm trying to solve for x. When I do that, I get back to negative pi over 2 is less than 3x subtract pi is less than pi over 2. I'm trying to solve for x, so I will add pi to both sides. Now, however you solve this inequality, as long as you're using correct algebraic steps, for example, doing the same thing to all sides, then you're fine. Negative pi over 2 plus pi gives me pi over 2 is less than 3x is less than 3 pi over 2. And then I am going to multiply both sides by 1/3 in order to get the x by itself. So I get pi over 6 is less than x is less than pi over 2. Sort of feels like I went around in circles. I'm sure I did there. But in any case, what we wanted to do was to restrict that argument of the function, the tangent function, to be between the normal, these are actually the range restrictions for the inverse tangent, but that's what we restrict the tangent function to in order to be invertible. Okay, so why does this matter? This part matters. My restricted domain is going to become my range of my inverse. So the restricted domain is just going to get copied right down here into my range of my f inverse. When we're doing inverse functions, the domain and the ranges swap. So whatever I restricted my domain to is going to be my range. So instead of saying x, I'll say y. So pi over 6 is less than x is less than pi over 2. Okay, now we need to go through sort of a similar process of solving for the y up here in the tangent function. Luckily in this problem, the tangent is already isolated. If I had something like a +1 right here, I would need to subtract it to get rid of it. Now I don't actually have that, so my tangent function is already isolated. My y value is stuck inside of this tangent function, so in order to get it out, I am going to apply an inverse. You could just translate this directly to saying inverse tangent of x equals 3 times y subtract pi over 3. Or you could go ahead and actually apply an inverse tangent function to both sides of this. Now either way you do this is fine because they're both going to get you to the same place. So I'm going to take the inverse tangent of x on the left and the inverse tangent of the tangent of 3 times y minus pi over 3 on the right, and then use the cancellation properties on the right. The cancellation properties actually only work if my argument is within a very particular restriction, but I've already taken care of that over here on the right-hand side. So I already know that I am going to get full cancellation, and I'll just get 3y minus pi over 3 on the inside. So I still need to solve for y. Because of the circles I went through over here on the right-hand side, I think I'm going to go ahead and just distribute that 3 through first before I solve. I have inverse tangent of x equals 3y subtract pi. Trying to get the y by itself, so I'll add pi to both sides. Inverse tangent of x plus pi equals 3y. And in order to get everything by itself on the right, get the y by itself, I divide by 3. And what I have done now is I've solved for my y, and that is going to be my f inverse of x. So my f inverse of x, you can write it as the inverse tangent of x plus pi, and that whole thing is divided by 3. Now, for the domain of this f inverse of x, it would actually be the range of my original function. You can just look here, I have an inverse tangent. I know just from the facts that I know about the inverse tangent functions that the domain of any inverse tangent function is negative, infinity to infinity. If this was a sine or a cosine function, you would have wanted to take the extra step. In addition to what we did finding the restricted domain, we would also want to figure out what the range of the original function was. If you look at the class notes from section 6.1, you can actually see that with the example we did there. So that is how you find an inverse trigonometric function. The most important thing that is different from regular inverse functions is this part where you have to restrict the domain of the original function, which is going to in turn be your range of your inverse function. So we restricted the restricted domain then becomes the range of the inverse. Now whatever the range of the original function was is the domain of the inverse. And that's it.